All right, guys, let's go ahead and get started. So today we're doing 6.6 altitude on hypotenuse. This is one of the more difficult sections within Unit 6, probably the most difficult. So let's go ahead and jump right in. Now, for altitude on hypotenuse, what's occurring each time is that we're going to be given a right triangle, because again, we're dealing with a hypotenuse, and we're going to have a right angle. And of course, our hypotenuse is opposite that right angle. Now, we're going to draw an altitude from the right angle of the right triangle to the hypotenuse. So this is our altitude on hypotenuse. Now, what happens here is it creates three different triangles. Of course, we have the large triangle, our original one, triangle ABC. And then we also now have the small triangle on the left side and the medium triangle on the right side. So what happens with this is it creates three similar triangles. So all three of these triangles are similar to one another. Now, further, I went ahead and matched up the corresponding parts for these. So as you can see, we have the small leg in red. We have the long leg in blue. And we have our hypotenuse in green. So each of these sides should be proportional because, again, all three triangles will be similar. So what this allows us to do, and I'll do a little example here between the small and the medium, is if I do a ratio of my short leg over my long leg, I would get x over h equals h over y. Of course, if we cross multiply, that turns into h squared equals x times h. Now, the interesting thing here is that we get a geometric mean. And when you're dealing with altitude on hypotenuse, you should always get a geometric mean, and that will be telling you that you're doing it correctly. So again, be looking for the geometric mean each time. And keep in mind, there are three different triangles here, very important for that as well. Now, make sure that when you guys set up your ratios, you keep the same triangle in the same ratio. We can see that right over here. I have my small triangle in this ratio. Right over here, we have our medium triangle. So h and y. And then we also have x and h. So just keep that in mind. Your ratios should be in the same triangle as well. Now, again, we have our three triangles here. So we're going to talk more about the similarity that's occurring. So since triangle ABC is similar to triangle ACD, we can set up a ratio. Now, if we look at this, we have AB, which is the hypotenuse, over AC, which is the short leg, is equal to the hypotenuse, which is AC, over the short leg, which is AD. Now, if I fill in with the variables for the side lengths, you'll notice something. It creates a geometric mean once again. So if we look at this, this is hypotenuse over short leg, which would give us C over B equals B over X. Again, hypotenuse over short leg equals hypotenuse over short leg. Now, if we cross multiply, of course, that'd give us b squared, and we know that we're on the right track because there's a geometric mean. These two are the same variable or the same number. And this would give us b squared equals c times x, which means that b is our mean proportional or geometric mean. Those are the same things. Mean proportional and geometric mean are the same. So AC is the mean proportional between the other two side lengths, segment AB and segment AD. Further, between triangle ACD, again, that's the small triangle, and our medium triangle CBD, these are also similar, so we can also set up ratios. So for this one, I'm going to use short leg over long leg. So if I look at my small triangle, AD is my short leg, CD is my long leg, so AD over CD. For our medium triangle, we have CD as our short leg and DB as our long leg. Of course, this would give us the ratio of x over h equals h over y. And we notice once again that we have a geometric mean, right? We're on the right track then. So when we cross multiply, we'd get h squared equals x times h, which means that CD is the geometric mean between AD and DB. All right, let's go ahead and move into our theorem. So the theorem for this is if an altitude is drawn to the hypotenuse of a right triangle, then two things occur. First of all three triangles, the small, medium, and large, will all be congruent to each other, similar to each other, not congruent, but similar. And further, the altitude to the hypotenuse is the mean proportional, meaning it's the geometric mean. So you'll notice that each time we'll get a geometric mean whenever we do these problems. And that's a great halfway point for you to be able to check and see if you're doing it correctly or not. So let's go ahead and try one of these out. Again, here's just showing all the corresponding parts as well. All right, so first off, we have x equals 3, y equals 9. We're trying to find the lengths of h and b. So we're going to go ahead and start off with h. Now, the first thing that we need to do with each of these problems is we always need to be thinking which triangles hold this variable. So if I'm looking for h is on our small triangle. It's our long leg here. And h is also on the medium triangle. It's our short leg. So we're going to do long leg and short leg. So my ratio will be long leg over short leg. So again, that will be h over 3 for my small triangle is equal to long leg over short leg, 9 over h. If we cross multiply, we'll be left with h squared equals 27. And then we can go ahead and get rid of the square by taking the square root of both sides, giving us h is about 5.2. Again, make sure that you're rounding to the nearest tenth. As for finding b, we're going to do the same type of process. We first think, which triangles is b on? Well, b is on our small triangle as the hypotenuse, and b is on our large triangle as the short leg. So we're going to use our small triangle and our large triangle, and we're going to be using the ratio of short leg over hypotenuse. So just writing out the variables to get started. I'm going to start with my large triangle. So I'm going to have short leg over hypotenuse. So that would be b over c for the large triangle. And then for the small triangle, we're going to have short leg, which is 3 over hypotenuse, which is b. So let's go ahead and write it all out. Short leg over hypotenuse. Again, b over c equals x over b. Again, we see a geometric mean. We're on the right track. Plugging in actual numbers. For c is the entire length of AB, so that'd just be 3 plus 9, which is 12. Meanwhile, x is just 3. So we're going to have b over 12 equals 3 over b. Cross multiplying, we'll get b squared equals 36. And taking the square root of 36 will give us b is equal to positive 6. All right, let's go ahead and try another one. This next one's going to be a little bit more difficult. Find x, y, and z. So for this problem, we're also going to start out just by looking at what is given to us. So we're going to start by solving for x. X would be the easiest for us to solve. We can start anywhere, but if we start with x, I'm just going to go in order, really. That's the only reason why. So it doesn't really matter where you start. So looking at x, which triangle is x on? Well, it's on the small triangle on the left side. It's our long leg over there. And it's also on our medium triangle. It's the short leg for the medium triangle. So we're going to have the ratio of long leg over short leg. So focusing on our small triangle first, that'll give us the ratio of x over 4. And for our medium triangle, that will give us the ratio of long leg, which is 5, over short leg, which is x. From here, we can go ahead and cross multiply. This will give us x squared equals 20. And then taking the square root of both sides to get x by itself, we're left with x is about 4.5. Next, we're going to solve for y, just because it's second. So we should be asking ourselves, on which triangles is y a part of? Well, y is on our small triangle. It's the hypotenuse on the small triangle. And then it's also on the large triangle. It's the short leg on our large triangle. So we're going to have the ratio of hypotenuse over short leg, and we're going to use our small triangle and our large triangle. So this will give us y over 4 equals 9 over y. Now again, this is my short leg, or sorry, my small triangle. So I have hypotenuse, which is y, over short leg 4. And it's equal to, on our large triangle, the hypotenuse of the large triangle is 4 plus 5, or 9, over the short leg, which is y. Again, we're on the right track because we have a geometric mean, so we can cross multiply, giving us y squared equals 36. And then once again, if we take the square root of 36, we'll be left with y is equal to positive 6. All right, then lastly, we're going to go ahead and solve for the variable z. So this time we think about which triangles is z a part of. Well, it's the hypotenuse on the medium triangle. It's opposite the 90-degree angle. And then on our large triangle, the whole thing, z is our long leg. So we're going to have long leg over hypotenuse using the medium triangle and the large triangle. Starting off with our large triangle, that will give us long leg, which is z, over hypotenuse, which is 9. So again, z is our long leg, hypotenuse is 9 on the large triangle. Then on the medium triangle, the long leg is 5, because 5 is bigger than 4.5. That just proves it further. But long leg is 5 over hypotenuse, which is z. Again, we see a geometric mean occurring. From here, we can cross multiply and solve. This will give us z squared equals 45. And taking the square root of both sides, we'll get z is about 6.7. All right. Pause the video if you need to. We're going to go ahead and move on, though. Our final question, find x. So we see x right here. We need to solve for it. So again, we look at which triangles x is a part of. Well, it's on the small triangle here, right? It's the short leg on the small triangle. And I also have the hypotenuse on the small triangle. So I'm going to use short leg and hypotenuse. Well, do I have short leg and hypotenuse on any other triangles here? Yeah. The large triangle, the big one overall. We have short leg of 7 and long leg, or sorry, hypotenuse of 10. So using short leg over hypotenuse, we'll have the ratio, or sorry, the proportion of 7 over 10 equals x over 7. Again, starting with this one, 7 is the short leg on the large triangle, 10 is the hypotenuse on the large triangle. For our small triangle, we are using this ratio. X is the short leg on the small triangle, 7 is the hypotenuse on the small triangle. We have a geometric mean occurring. These are both 7, so we can continue working because we're doing it correctly. Cross multiplying will give us 10x equals 49. And then dividing both sides by 10 to get x isolated will leave us with x equals 4.9. And that's our final answer. All right, guys, that is it for 6.6 altitude on hypotenuse. If you guys have any questions or need anything, just let me know. But thank you guys so much for watching and have a great